Okay, I know we talked about graphing rational functions in class, but if you were absent or if you need a little more instruction or practice, I made a video for you with a few different examples. Maybe not every kind of rational function you'll encounter, but some of them. All right, the steps for graphing a rational function are to factor first, and then the next thing you want to do is find holes. Holes are where any factors that cancel out. Need my pencil. So those are found where factors cancel out. And vertical asymptotes. Those are values that make your denominator equal to 0. That you haven't canceled out. So horizontal asymptotes, if the degree of your numerator is greater than the degree of the denominator, there will be no horizontal asymptote. If the degree of your numerator is less than the degree of your denominator, then you have a horizontal asymptote at y equals 0, just like we discussed in class. And if the degree of your numerator equals the degree of your denominator, just like we talked about in class, it's the ratio of your leading coefficients in your numerator over your denominator. Okay? So x and y intercepts. To find your x-intercept, you set y equal to 0. And then for your y-intercept, you do the opposite and you set x equal to 0. And you get the coordinates for your x and y intercepts that way. And last, you're going to need to plot points. And to do that, you're going to need to plug in values for x. Around your vertical asymptotes. And any other places you're unsure of. Okay, so let's get down to business and start graphing these. The first example I have is negative 2x squared plus 2x over x squared minus 9. So again, your first step is always to factor. If I factor out negative 2x in the top, that leaves me with x minus 1. And in the bottom I have x plus 3 times x minus 3. You can see here that in my numerator and my denominator I don't have any factors that cancel out, so I have no holes. No holes in my graph. And a hole in my graph looks like a hole in the graph with values that approach that hole on both sides. So let's look for vertical asymptotes now. If I set my denominator equal to 0, then the values of x that would make this undefined are x equals plus or minus negative 3. So I have an asymptote at plus or minus negative 3. So I'm going to draw those in. You should draw in any asymptotes with a dashed line. Your function will never cross a vertical asymptote. And the difference between an asymptote and a hole is if I have an asymptote, then on each side of my asymptote, my function either goes to positive or negative infinity. Whereas in a hole, it just approaches the value of the hole, and then there's like a hole in the graph. That's the difference between a hole and an asymptote. Okay, so now let's look at horizontal asymptotes. You can see here that my degree of my denominator is 2, and the highest degree in my numerator is also 2. So the degree of the denominator equals the degree in my numerator. That means that I have a horizontal asymptote at -2 over 1 because -2 is the leading coefficient in the numerator, and there's an invisible 1 in front of x squared. So my horizontal asymptote is at y equals -2. I'm going to go ahead and draw that in. All right, and now I need to plot my x and y intercepts. I have let's do the y-intercept first. At my y-intercept, x is equal to 0. If I put a 0 in for x, this term is gone and this term is gone and this term is gone. So I'm left with 0 over -9. Anything, 0 divided by anything except for 0 is 0. So I have a point at 0, 0. All right, and if I want to solve for my x-intercept, well, that means that y is equal to 0. Now that's a little more interesting in this case, because if I set my fraction equal to 0, well, actually, if I set any fraction equal to 0, the only time my fraction here would be equal to 0 is if the numerator equals 0. If the denominator equals 0, it's undefined. So I don't really need to worry about this. I just need to solve the top for when y equals 0. And again, I'm going to put that back into factored form and use the zero product property. I have two places here where this would be true. That would be if x equals 0 or x minus 1 equals 0, which would mean that x would be equal to 1. So x is either equal to 0 or 1 at the y-intercept. So I have a point here. Also, I already have the 0, 0 plotted. I also have a point at 1, 0. So I have 2 points here. The last part of this graphing, I'm going to erase everything else I have just to clean this up a little bit. The last thing I need to do is to figure out where the other points in my graph lie. So to do that, I can always do that by making a t-chart and plugging in values. And the more you practice doing graphs of rational functions, the better you're going to get at picking values to plug in. You should always check on either side of your vertical asymptote. You want to check to the left and to the right of both of those. And then you want to check maybe a bigger value of negative x and maybe a bigger value of positive x. Those are good places to start. So if I want to know where my graph is in this section over here, let me get a laser out so I can show you what I mean. So I have this section over here to the left of my vertical asymptote where x is -3. If I need to figure out where that goes, well, I'm going to plug in a couple values over there. All right, so a good place would be over here, just to the left of this, at x equals -4. And then I could also plug in a bigger negative value just to see what's happening. So I'm going to check those two values and see if I can figure out where to plot this. Well, when I plug in x equals -10 into the function here, I end up getting y is -2.4. And if I plug in -4, I end up getting y equals -5.71. we'll just do negative 5.7. So you can see that my function is going to do this because this is going to approach the horizontal asymptote on this side, and on this side it's going to either go to positive or negative infinity. But this is less than negative 10, so it's going to go to negative infinity. And if you're not sure, plug in negative 3.1 and see what that value is. It should be more negative than negative 5.7. All right, so now I need to figure out what happens in this quadrant. If I had to guess, I would guess, let's put in a different color for my guess. Let's put it as green. If I had to guess, because of those 2 points there, I'd say it looks something like this. But let's double check just to make sure. So I need to check a value to the right of this asymptote. So I'm going to check negative 2. And then I'm also going to check this side here at x equals 2. When I plug those into my function, negative 2 gives me 2.4. And positive 2 gives me 0.8. So this function does indeed do something like this. Remember, around my vertical asymptotes, it's either going to go to positive or negative infinity. The last quadrant or section I need to check is this over here to the right of my other vertical asymptote. And a good place to check is x equals 4 and x equals 10, because 4 is to the right of that. And then just to get a good check of that, I want to check something over here on this side. So over here, I'm either going to be here or here, above or below that horizontal asymptote. And over here, I'm either going to be above the horizontal asymptote or below, and that's going to tell me which quadrant to draw that function in. So when I check for x equals 4, I get negative 3.4-ish. And when I check x equals 10, I get negative 1.9 something. So my graph looks like this. And if you're unsure, go ahead and check some other ones. All right, I have a second example for you. Okay, my second example, I'm going to factor, again, x minus 2 times x minus 1. That's what my top factors into, and my bottom factors into negative 4 times x plus 3 times x minus 3. You can redistribute that if you don't believe me. All right, so if you look here, I don't have any holes because none of my factors cancel out. I have two vertical asymptotes because if x were negative 3, I'd have a 0 times 0 in the bottom. That would be undefined. Or if x was positive 3, I'd have the same situation. So if I draw those in, they look disturbingly familiar to the last graph. You'd think the software I used could generate something a little bit different, but whatever. Okay, and then horizontal asymptotes. We have to look at the degree of the numerator and the degree of the denominator. Since they're equal, it's going to be the ratio of my leading coefficients in my numerator. I have an invisible 1, and in my denominator I have negative 4. So that makes my horizontal asymptote at y equals negative 1/4. That's about here. Good enough for government work. Okay. Now, if I want to find the x-intercept, well, that means that y is equal to 0. And since this is a fraction, the only time that this is going to be equal to 0 is if my numerator equals 0. So if I set that equal to 0 using the zero product property and try to solve it, that means that x is either 2 or 1. So let's go ahead and plot those at 1 and 2. And then my, oops, wrong spot, 2, 0, and 1, 0. And my y-intercept means that x is equal to 0. And if I put a 0 in here, this is 0 minus 0 plus 2. This would be 0. And then I'd have 36 in the bottom, which simplifies down into 1 over 18. So y would be equal to 1 over 18. That's going to be kind of tricky to graph, but you get the idea. I'll plot a point here, really close to the axis. All right, let's erase all of this stuff. Now I got to figure out where to plot my points. What you really need to check is points around your vertical asymptote, maybe a bigger point further out. So I need to look to the left of my first vertical asymptote, which is at -3, and I'm going to check -4. And I'm going to also check a value further out in my graph. So I'll go with -10 because I can still plot that. When I plug in -4, I end up with around -1.1. All right, so that is below my asymptote, somewhere down here. And when I plug in -10, I get -0.36-ish. So that's still below here, but it's approaching that asymptote. Oop, don't cross that line, please. All right, and then I need to check values to the right of that asymptote and to the left of the next one. So for those, I'm going to plug in, let's see, -2 would be a good spot, and +2 would be a good spot. I already have a good idea of what that asymptote's going to do because of these points here, but just to be sure, I'm going to plug in values. All right, so when I plug in -2, I get 0.6, and if I forgot that at 2 I have a value at 0, so maybe I'll check 2.5. When I do that, I get 0.07. Okay, so looks something like this. And then if I check values on this side, I have x equals 4, and then again I want to just double check and do x equals 10. When I plug in 4, I get -0.21-ish, and for 10 I get -0.2. So those are both below this asymptote, which means this is going to shoot off down to -infinity. And if you're unsure, you could check 3.1 and you should get a large number. All right, my last example, factor. I can factor out an x, and I'm left with x squared plus 2x minus 8, which factors down further into x plus 4 times x minus 2. And then in the bottom I can factor out a 4, and I can factor that further down into x minus, and x plus 1. All right, no holes because nothing cancels out again, but I have vertical asymptotes at x equals positive 3 and negative 1. So let's draw those in. And then horizontal asymptote. If you look here, the highest degree in the numerator is 3. The highest degree in the denominator is 2. This is larger than this, which means this is going to grow faster than this does. Even though this is growing, this grows faster, which means I don't have a horizontal asymptote. Actually, a better way to put that is just to write none. All right, and then our y-intercept means x is 0, which would be 0 plus 0 plus minus 0 over 12. So that means that I have the x-intercept is at 0, 0. So let's plot that. The y-intercept, sorry. X-intercept, that would mean that y is equal to 0. And that means my numerator would have to equal 0. And I have 3 places that means that x is equal to 0, negative 4, or positive 2. So let's plot those points. Let's see, negative 4 is over here. 0 I already have, and 2. Okay, so that's my points I have. Now I just need to check for values so I know how to graph this. I need to check over to the right or the left of my vertical asymptote, and then the needed value is larger. Let's get rid of this stuff. How come I can't get rid of that? It's like I wrote on it with the wrong kind of marker. Haha, just kidding. Okay. So checking. Let's check x equals negative 2 and negative 10. So negative 2, I get a y value of 0.8, and negative 10, oh, yeah, that's right, and I get about negative 1.5-ish. So negative 2 is here, and negative 10 is about negative 1.5, so about here. Looks like this. All right, and then I want to check, I know I have 0, and I know I have a value at 2, so those are going to be a little bit trickier to check. I'm going to check negative 1/2, since I have a value at 0. And I have an asymptote at negative 1. I want to know if my function approaches positive infinity or negative infinity. And I'll be able to tell that by whether it's positive or negative. Let's get rid of that. Okay. So when I plug in negative 1/2 into the function, I get negative 0.63-ish, which means it's headed this way. And so I need to check this side too. Let's check 2.5 or 5/2. If I plug that into my function, negative 2 or positive 2.5 into my function gives me negative 3.4-ish. So that's going to come back and go down that direction. Now I just need to figure out what the rest of the function does. So on this side of my asymptote, it's either going to come from up here or it's going to come from down here. I don't know which. So let's plug in a 4 and a 10, because 4 is right to the right side of that vertical asymptote, and 10 tells me what happens to the function further out this direction. All right, so if I plug in a 4, I get 3.2. That is a positive number, so it's coming from this direction. Looks like my function is probably going to do that, because it looks like I have some kind of asymptote there. But let's check 10 just to be sure. If I plug in a 10, I get 3.64. So yeah, that's what this does. All right, that's it. If you still need help with graphing, please see me for extra help during, before school or after.